Ionic bond or electrovalent bond. Ionic bond is obtained by the complete transference of one or more electrons of one atom to the other atom. Okay? Ionic bond is obtained by the complete transference of one or more electrons from one atom to the other. Okay, so during this process, both the atoms acquired an octet. Okay, so one atom loses its electron and the other atom gains electrons. Okay, the atom which gains electrons gets negative charge. Okay, get negative charge. And atom which loses electrons get positive charge. Okay, so these two oppositely charged ions, that is one atom gains electron means that gets negative charge. So negative ion and positive ion, they are oppositely charged. So these oppositely charged ions attract each other by electrostatic force of attraction and they hold together. Okay, so the ionic bond means the electrostatic force of attraction which holds the oppositely charged ions together. So ionic bond means the attractive force which holds the two oppositely charged ions. Okay, hold together. Okay, and the compounds obtained by this ionic bond are known as ionic compounds. Compounds obtained are known as ionic compounds. Let's just take few examples. Example, formation of NaCl. Na configuration is 281. That is, sodium contains one electron in its outermost shell. This is the Lewis symbol. Plus chlorine. Chlorine contains 7 electrons in its outermost shell. Okay, so here sodium loses its electron and chlorine gains that electron. So sodium gets positive charge and chlorine gains that electron and it gets a octet electronic configuration. So 8 electrons in the outermost shell. Sodium also, by losing, it gets 8 electrons in the outermost shell. So it acquires octet. Okay, this changes to minus ion. So Na plus ion and chlorine minus, these two attract each other and form a bond and NaCl is obtained. Okay, next another example, CaF2. Here calcium. Calcium contains 2 electrons in its outermost shell. Okay. Then fluorine, 7 electrons in its outermost shell. Okay. So it needs one more electron. So it gains one electron here from calcium and this also gains one electron. So calcium gets 2 plus charge because it loses 2 electrons and it gets 2 plus. So fluorine gets minus charge. Then calcium. Calcium gets positive 2 plus charge. And fluorine, here also it gets minus charge. Okay, so the product obtained is CaF2. Okay, like this ionic compounds are obtained. Okay, now what is mean by electrovalency? Electrovalency. Electrovalency means number of electrons an atom gain or loss during this formation of ionic bond is known as electrovalency. So here this loses 1 electron. That means sodium, the electrovalency or valency of sodium is 1. Chlorine is also having the valency 1. Then fluorine is also having valency 1. What about calcium? Calcium, it loses 2 electrons. So it gets valency 2. So this will be the electrovalency. Okay. Next, factors favoring the formation of ionic bond. First one is ionization energy or ionization enthalpy. Ionization energy means the energy required to release an electron from the outermost shell. Okay. So during the formation of ionic bond, electropositive atom loses its electrons. Okay, loses its electron. So it requires ionization energy. Okay. Ionization energy. Okay, so lesser the ionization energy, easier will be the electron removal. Okay, so lesser ionization energy means the ionic bond can be formed easier. So lesser ionization energy, easier will be the bond formation. Okay. Example, alkali metals and alkaline earth metals are highly electropositive. Okay, so they require less ionization energy to liberate the electron from the outermost shell. So they can readily form ionic compounds. So alkali metals and alkaline earth metals readily forms ionic bonds. Okay, ionic compounds readily okay. Second one is electron gain enthalpy. So more electronegative atoms during the formation of ionic bond, what will happen? They gain electrons. So in order to gain electrons, some energy is released. That is electron gain enthalpy. That is the negative value of electron gain enthalpy is high. Okay, what will happen? The electronegative atoms can converted into anions easily. Okay, they can convert into ions easily or anions. So they can gain electrons easily. Okay, negative value of electron gain enthalpy is more, or we can say electron affinity is more, means more energy is released. Okay, easier will be the ionic bond formation. Okay, easier will be the ionic bond formation. Okay, so electron gain, higher negative gain enthalpy favors the tendency to form ionic bond. Okay. Next, lattice energy or lattice enthalpy. It is defined as the energy required to completely separate 1 mole of an ionic compound into its gaseous constituent ions. Okay, so it is defined as the energy required to completely separate the 1 mole of an ionic compound into its gaseous constituent ions. Okay. So this means if we take an example, NaCl. NaCl is formed and the energy required to completely separate Na and Cl minus from the bond is known as lattice energy. Okay. Now, higher the value of lattice energy, what will happen? It is easy to form the ionic bond. Okay. So, higher the lattice energy, greater will be the tendency for the formation of ionic bond, or greater will be the stability of the ionic bond. Okay. So, we can say higher the value of lattice energy, what will happen? Greater will be the tendency for to form ionic bond. Or we can say greater the stability of ionic compound. Okay, stability of ionic compound. Okay, so also there are different factors which affects the lattice energy, that we will discuss one by one. First one is size of the atom. Lattice energy depends upon the size of the atom, and the second one is charge on the ion. Okay, factors affecting lattice energy. First one is size of the atom. So what will happen to the lattice energy if the size of the atom decreases? Smaller the size, what will happen? Greater will be the inter-ionic force of attraction. Okay, greater will be the inter-ionic attraction. So greater will be the lattice energy. Okay, that means more easier will be the formation of the ionic bond, or more stable will be the compound. Okay, so size of the atom, smaller the size, what will happen? Is inter-ionic force of attraction increases. Okay, smaller the size, inter-ionic attraction increases. So lattice energy also increases. That means more easier will be the compound obtained, or more stable the compound. Okay, example in the case of NaCl and KCl, we can take NaCl. NaCl, the lattice energy is found to be 788 kilojoule mole inverse. And in the case of KCl, lattice energy is found to be 719 kilojoule mole inverse. So, which compound will be more stable? NaCl, because it is having more lattice energy. Now, second one is charge on the ion. What will happen? Larger the magnitude of the charge, that means the attractive force between them will be more. That means lattice energy increases and more stable will be the compound. Okay. So, greater the magnitude of charge, what will happen? Inter-ionic attraction increases. So, lattice energy increases and more stable will be the compound. So compound can be formed readily. So in short we can say that what are the different factors which affects the ionic bond. First one is ionization energy. Greater the ionization energy, easier will be the bond formation. Okay. Second one, electron gain enthalpy. Greater the negative value of electron gain enthalpy, or we can say electron affinity, easier will be the bond formation. Also, greater the lattice energy, what will happen? The ionic bond formation will be easier. And also, the lattice energy depends on two factors, size of the atom and charge on the ion. If the size and charge of the ion is more, greater will be the lattice energy and easier will be the bond formation. These are the different factors which affects the ionic bond. Okay.